We want to find a fourth degree Taylor polynomial for f of x equal cosine x centered at 0, and then we want to find all positive values of x for which this approximation is within 0.005 of the exact answer. So we're going to start by finding the function at 0. Cosine of 0 is 1. We're going to need 4 derivatives evaluated at 0. First derivative is negative sine x, and evaluating that at 0, we get 0. Second derivative is going to be negative cosine x, and evaluating that at 0 is going to be negative 1. Third derivative is going to be sine x, and evaluating that at 0 is going to be 0. And fourth derivative is going to be cosine x, and evaluating that at 0 is going to be 1. We're now ready to build the Taylor polynomial then. That's going to be our first one, which was 1. And then our x term, we got a 0 here, so that's gone. And then we have a negative 1, so that's going to be negative x squared over 2 factorial. Then we got a 0 term for our cubed, and then we have plus, got a 1 here, times x to the 4th over 4 factorial. 4 factorial is 48. So there is our fourth degree Taylor polynomial that will approximate cosine x at 0. Now we want to find all positive values of x for which this approximation is within 0.005 of the exact answer. In order to do that, we are going to use the alternating series estimation theorem. And what this says is if we have the sum of n terms of an alternating series and the n plus 1 term of b, so we have the negative 1 to the n minus 1 and then b to the n, and if the b to the n plus 1 is going to be less than or equal to b to the n, and if the limit of these b to the n terms as n goes to infinity is going to 0, then the magnitude of the remainder is the difference between the partial sum of these n terms minus the sum of all the terms after that, and so just that difference, and that's going to be less than or equal to the b sub n plus 1 term. So that's what we're going to use. We have this and this. So if we want to know the remainder here, that's going to be less than or equal to, and so that one we know is going to be, and we're after the positive values only, so we know that's going to be 1 over 6 factorial and then x to the 6th. And then what we can do, say we need to find the x's, so that this is going to be less than or equal to 0.005. So we need x to the 6th to be less than or equal to 0.005 multiplied by 6 factorial. And now then x would just need to be less than or equal to, we have that 0.005 times 6 factorial, and we would need the 6th root of that. So now we could grab a calculator and ask the calculator for 0.005 times 6 factorial, that quantity to the 1/6 power, and we see that we would get 1.238. So what that tells us is we would need our x then to be less than or equal to 1.238, and we would know we would be within 0.005 of the exact answer by using this fourth degree Taylor polynomial.